Hello, dear learners. Myself, Professor Jitendra Sarwa from Department of Geography of Dr. Bhimrao Ambedkar College, University of Delhi. Today, I am going to discuss the topic Theories of the Origin of Submarine Canyons. Part 1. As there are many theories, we are going to describe 6 theories, 3 in part 1 and 3 in part 2. So this particular topic is part of core course of Oceanography, which is paper in MSc Geography of IGNOU program. Scholars have tried to explain the origin of canyons based on a number of theoretical principles, some of which are quite divergent. As all of you know that basically there are two types of forces which are responsible for the formation of landforms: endogenetic and exogenetic. Endogenetic processes, they operate beneath the earth's surface, and exogenetic processes, they operate over the earth's surface. If they operate over the continental, that is beneath atmosphere, then those landforms are known as subaerial. If they are operating over the earth's surface but underwater in the oceanic environment, then they will be known as submarine landforms. So submarine canyons are also formed by these two types of forces, endogenetic and exogenetic. The theory related to endogenetic origin of submarine canyons is known as diastrophic theory of submarine canyons origin. In addition to this diastrophic theory, we have other following theories. Number 2, if number 1 is diastrophic theory, then number 2 is subaerial erosion theory. Then we have submarine mud flow and landslides theory. Then we have submarine density currents, submarine turbidity currents, submarine ground sapping and spring sapping. In diastrophic theory, the scholars, they consider that submarine canyons have been formed due to the Earth's movement and tectonic processes or endogenetic forces. These endogenetic forces, through compressional and tensional processes, basically result into faulting, folding, warping on regional scale, and subsidence of the sea floor due to endogenetic processes. Local displacement due to endogenetic forces can lead to fracturing or faulting and folding of the ocean crust. The grabens and silk-nylon basins formed under the impact of such forces, tensional and compressional, may appear as submarine canyons. This diagram on the upper side represents formation of a graben due to the process of faulting. So the middle part is basically down faulted part, and over the period of time it will become a submarine canyon according to this theory of diastrophic origin. And the lower part of the present slide represents folding or warping. So down folded part or synclinal part of this fold or warp represents again that submarine canyons. So scholar Andrade stated that the canyons consist of a series of graben-like valleys and are formed during very gradual local coastal displacements. The term diastrophic force itself represents slow and gradual process. So they are produced by faulting as a fault trough or a graben, or as synclinal basins by down warping or down folding. So this is the basic idea. So according to diastrophic theory, submarine canyons are basically the troughs or grabens formed by the faulting process or the synclinal basins formed by compressional forces which represent the down folded part or downward parts of the fold. at local or regional level. Scholar Lawson identified one such tectonic canyon off the coast of California as an evidence, as an example, or to prove this particular explanation. Such canyons are also present near the coast of Cyprus and Morocco. Scholars Jensen and Burkhardt considered the continental border area as a zone of flexure due to the contrasting presence of Sial and Sima rocks. We all know continental crust is known as Sial because of dominance of silicon and aluminium, and oceanic crust is known as Sima. On the continental side, the denudation, and on the coastal marine side, deposition results into uplift of land and subsidence of sea floor due to increased pressure, and due to reduced pressure it gets uplifted, and due to increased pressure it gets subsided, and this results into isostatic adjustments. Subsurface convectional currents, they move from sea to land, and they also give momentum to that upliftment, and then as a convectional current they again give momentum to that subsidence process. Occasional cooling of magma beneath the sea floor enhances its subsidence. These tectonic, isostatic, and magmatic processes create fault-like valleys or downfolded parts or areas of subsidence which are present in the form of submarine canyons according to this particular theory. Though this theory of origin of submarine canyons seems to be plausible in general, it is criticized on three main grounds. First, most of the submarine canyons are found transverse to the coast, whereas faulting generally occurs parallel to the coast. So, alignment of faults is not there along with the direction of majority of the submarine canyons. Second, many of the submarine canyons display a dendritic pattern. Dendritic pattern means tree type. There is major trunk, then sub branches, then sub branches. So overall appearance is like a tree. So dendritic pattern, which is also common in case of rivers, dendritic drainage pattern. So dendritic pattern with branches and sub branches, and such a pattern cannot be explained in terms of processes like faulting, folding, warping, which are linear and without any sub branches. So this way, this is also a contradiction. Then third objection is on the ground that not all continental shelves and slopes where such canyons occur display evidence of crustal instability and associated faulting and faulting. So submarine canyons are also present in areas which are geologically stable, means there is absence of activities like folding, faulting, or magmatic activities. So therefore their formation cannot be explained on the basis of diastrophic theory. So to overcome these challenges, some other scholars have put forward the theory of subaerial erosion for the formation of submarine canyons. Based on the size and shape, the winding nature, tributaries, and steep slopes on the sides of the submarine canyons, and their similarity with subaerial river valley canyons and their location along the major river mouths, Shepherd, Hull, and Dana conceptualized their origin as a result of subaerial erosion. Because of the resemblance of submarine canyons to the canyons on the land, many scholars have opined that these canyons have been formed through entrenchment of valleys by rivers and their subsequent drowning due to subsidence and submergence of coastal areas. Theoretically, subaerial erosion I have explained. Subaerial erosion is erosion on the continental parts, that is beneath air. If there is erosion on the seabed beneath water, then that will be known as submarine. So theoretically, subaerial erosion of canyons is possible only through two ways. First is either the land where present day submarine canyons are present was uplifted above the sea level, on which the valleys were carved out and which subsequently subsided and it became submarine locationally, or the sea level, these are present day submarine canyons areas, continental shelf and slopes, and sea level was lowered, retreated for a short period, during which this area became subaerial and canyons were subaerially carved out, and as sea level kept on increasing and regained its normal present day level, they were submerged as submarine canyons. So according to Shepherd, canyons originated due to subaerial erosion at the time of emergence of land. Later, after subsidence, they obliterated due to terrigenous. Terrigenous is that deposits which come from terra. Terra means land, continental side. So terrigenous and pelagic deposits. Pelagic is within the sea deposits. And they were carved out again by mass wasting, that is downsliding, movement due to slope or gravity, and water sapping processes. This theory is based on the belief that rivers eroded their valleys to form deep gorges during the periods of rising base level due to the emergence of landmass. As it kept on rising, so vertical erosion continued, and vertical erosion resulted into the formation of deep and steep-sided submarine canyons. Steepening gradients of such valleys provided energy for rapid erosion, or you can say valley deepening, and thus leading to the formation of deep, narrow gorges. When the continental margins subsided in later times, these valleys were occupied by sea, and long, deep canyons were thus formed on the seabed. While some scholars have ascribed such submergence of former river gorges to the subsidence of land, as I told you, another option is others, they have ascribed the rise in sea level to the retreat of glaciers after the ice age for the formation of subaerial conditions for erosion. It is true that many of the submarine canyons are associated with existing river systems on land and seem to have been formed on the continental shelf during a period of lower sea level, that is during the phase of advancing glaciation. Although such an association of some of the submarine canyons with the existing river systems gives credence to this theory, the idea of subaerial erosion being the common cause of formation of these features has, again, like diastrophic theory, it has also some limitations. So three major limitations are: first, the formation of submarine canyons through subaerial erosion would have required a vertical movement of land in comparison to sea level, or downward movement of sea level of a magnitude of hundreds of meters, or an equivalent change in the sea level due to climatic changes, which is not possible, and we do not have the evidences, because the depth of the submarine canyons on an average is 600 to 900 meters, and in some cases it even extends up to 3000 meters. So that level of upliftment of the continental shelves and slopes, and that amount of fall in sea level is not possible, and we do not have the evidences from the past for such changes on such large scale. Second, if this theory is taken as true, then the submarine canyon should extend up to the coasts. But normally they don't extend up to the coast, though they extend up to the continental shelf. But we have also evidences. We have also submarine canyons which are confined to only continental slope areas, and they are absent on the continental shelf area, which are known as headless submarine canyons. So this particular explanation, subaerial erosion explanation, fails to explain presence of those submarine canyons which are confined to continental slope areas. However, in fact, many of the canyons are situated far away from the river mouths. So this is a contradiction. The third objection is, though the Pleistocene time period glaciation led to a lowering of sea level and retreat of glaciers, later led to a rise in sea level, which is still rising on, these changes in sea level fail to explain the great depths of up to 2000, 3000 meters of many of the submarine canyons. Geomorphologist W.M. Davis also discarded this idea of formation of submarine canyons by subaerial geomorphic processes due to the huge amount of upliftment or submergence of sea required to prove this particular explanation. So on these three grounds, this idea was rejected and it failed to explain the origin of all the submarine canyons. In 1932, the scholar Shepherd presented another explanation for the formation of submarine canyons, and this time he applied the concept of mud flow and landslides. So this is known as mud flow and landslides theory. Shepherd assumed that canyons are older than the continental shelves, and they were developed on uplifted land. They were formed during Paleozoic era. There were depressions on land due to various regions, maybe eroded areas by rivers as river valleys, or due to landslides, or due to faulting, etc. Before the advent of the Pleistocene Ice Age, these depressions were partially filled with terrigenous debris, and glaciations resulted into fall in sea level, and water continued to flow through these canyon valleys and into the ocean. The powerful water currents continued to remove the debris from these canyons, so that the pre-existing canyons were incised deeper and deeper. With rise in sea level, these deposits of sediments were removed in submarine environment by mud flows and landslides. These mud flows resulted into lateral erosion of valleys and also vertical erosion, deepening of valleys also. Shepherd and Emre in 1941 pointed out that the mud flows keep the canyons clear of the unconsolidated debris and maintain steep side slopes with the presence of outcrops. Occasionally, seismic jolts, and if we go in terms of geological history, then it will become repetitive also. So seismic jolts contribute in loosening of the deposited materials and trigger landslides in these canyons. The buried or suspended cables were used as evidence by Shepherd and Emery in favor of landslides. When the cables were found displaced and also buried beneath the sediments. This explanation of Shepherd gives greater weightage to mud flows and landslides in clearing the submerged ancient valleys, and it is not supported by absence of greater sedimentation at their mouths. The age of sediments in most of the canyons belongs to the tertiary period and not as old as assumed in this theory, because in this theory it is assumed to be of age of Paleozoic era, but actually age of sediments belongs to tertiary period, which is very young period. Another limitation of this theory or explanation is the absence of proof in support of regular phenomena of landslides. Landslides are also occasional. So, this theory fails to explain the formation of all the submarine canyons and features like submarine canyons. Thank you very much.